So one thing I left out of the previous video is consistent and inconsistent systems. Basically, consistent systems are systems that have a solution. So if they're crossing, right, if there's a point of intersection, then that means that it is a consistent system of equations. Okay, if the lines are parallel, right, the lines of the function are parallel and they're not intersecting, meaning there's no solution to the systems of equations, then that means they are inconsistent. Okay, you can remember mnemonic crossing for consistent, and if you think about it, when they're parallel and there's no point of intersection and they're not crossing, there's a little I there, so they're inconsistent, like that. Okay, now moving on to systems of inequalities. Okay, so this is a good question. They want to know the inequality represented by the graph, meaning like y is greater than or less than or equal to something times x plus something, right? Just like with lines, right? We know y equals mx plus b, where m is the slope and b is the y-intercept, meaning where the line reaches the y-axis. So it's similar with inequalities, just instead of equals, there's a greater than or less than, or greater and equals, less than and equals, etc. So the first thing to notice is the shaded region over here is above the line. That means it's going to be y is greater than. Okay, y is greater than. Next thing to note is that it's a dotted line, meaning it's only greater than, but not equals to. So we're not going to put an equals to sign. If the line was solid, we would say or equals to. But it's not. So the next thing to do is let's find the slope. So we could pick any 2 points. It's easiest to use points that you can clearly identify where they are. So let's say here to here is 2 to the right and 1 up. So we know it's rise over run. So it goes up 1 over the course of 1, 2. So 2 to the right, up 1, therefore it has a slope of 1/2. Okay, so it's y is greater than 1/2 x plus b. Now we just have to find the y-intercept. That's going to be where it hits the y-axis, where x is 0, and that over here is going to be 2. So that's all there is to it. Y is greater than 1/2 x plus 2. Let's try this one. First try it on your own, see if you can do it. And now you can pause the video. Now I'm going to solve it. Okay, so the first thing to notice is it's going to be less than. Y is less than, right? Because the shaded region is down here. And it's a solid line, so that means it's going to be y is less than or equal to. Remember, you should write on top y equals mx plus b, just as a signpost to know what you should be looking for. So the slope is going to be, so let's see, we always go from right to left, right? So this is a downward slope, so it's going to be negative. So the rise, which is negative here because it's going down, is -1 over how much does x change in the span when y goes down 1? 1, 2, 3. It goes down 1 for every 3 to the right. So that's a slope of -1/3 x plus b. B is the y-intercept where x is 0 and it hits the y-axis. So as we can see, that's going to be where y is 1, right there. So that's our answer. Y is less than or equal to -1/3 x plus 1. Okay. Now over here, it's a little bit tricky because you have to do a drop of algebra to get y alone first. So we have 7x minus 2y is less than or equal to 5. Subtract, we want to get y alone, right? So subtract 7x from each side. We get negative 2y. Y is less than or equal to 5 minus 7x. You could divide now by negative 2. Don't forget to switch the sign. Y is greater than negative 5 over 2 plus 7x over 2. So we can see that it's going to be y is greater than, so that eliminates choice B and C. And actually we don't even have to do anything difficult here, because as we can see, it's less than or equal to, so it has to be a solid line. So we know straight away that it's got to be D. But if it wasn't so obvious, we can use the fact that the slope over here is going to be 7 over 2, and the y-intercept is negative 5 over 2 to help us find the answer. But when y isn't alone and you want to graph it, you got to do a drop of algebra to get y alone. Okay, this is super easy. This is the plugging in again. So we'll do a couple of these, not too many. So we're checking to see if 3, 4 is a solution for this inequality, if it fits that inequality. So let's write it out. Y is less than 4x minus 2. Careful not to mix them up. X is 3, y is 4. Bring everything down. 1 is less than 12 minus 2. So yes, that is true. 4 is less than 10. So the answer would be yes, this is a solution. It does fit. Again, you should be trying these on your own before watching me do it. X minus 7y is less than or equal to negative 10. X is 2. Y is 4. 4 minus 28 less than 10. So yeah, this is clearly going to fit, because negative 24 is less than negative 10. Y is less than or equal to negative 5x plus 3. Careful not to mix them up. X is 3, y is negative 3. Negative 5, bring that down, plus 3. And so it looks like this is not going to fit with the system of equations, because negative 3 is not less than negative 12, so it is not a solution to this inequality. Sorry, not system. Okay. Again. Going again, careful not to mix up. X is negative 3. Y is 2. So we get negative 12 minus 20 less than negative 9. Remember, if you don't have adding and subtracting with negative numbers down pat, check with your calculator. Use it. This is going to be negative 32, which is indeed less than negative 9. So this point is a solution to this equation. I think this will be the last one. Y is less than 7 plus 8. So careful not to mix them up. Y is negative 6, X is negative 2. Remember, use your calculator. Negative 14 plus 8 is going to be negative 6. So this is not true because these are equal. Negative 6 is not less than negative 6. So this does not fit in the system of equations. This would be on the line and on a dotted line because it's only less than, not equals to. Okay, I think we did enough of those. Okay, this is super easy as long as you know how the coordinate system works. Is 1, 3 a solution to the graphed inequality? Well, just find the point 1, 3, which is 1 to the right, 3 up. So that clearly is within the region right there. So it is a solution to the inequality. Negative 2, 0. So negative 2 means 2 to the left, 0. Ooh, so it's on the line, but it's a dotted line, which means that it's only greater than, but this is on the line. So this would not be a solution to this inequality. Negative 2, 3. That means 2 to the left and 3 up. 1, 2, 3. This is also on the line, but here it's a solid line, so this would be a solution to the inequality. Negative 2, 2. So that's 2 to the left and 2 up. That is within the region. Last one of these. 1, 3. 1 to the right and 3 up. That clearly is within the inequality. Okay, this is the last one for inequalities. Is it a solution to the system of equalities? So one line is shaded up like this. The other line is shaded up from here. This region only fits with one of them. This region only fits with the other. This dark green region fits with both. So for a solution to be a solution to the system of equations, it needs to be in the shaded region that's shaded by both inequalities. So 3, 1, 1, 2, 3, 1. That clearly is within the region shaded by both of them. So that would be a solution to the system of inequalities.